We're on question 16. Jim's investment has a present value of $9,000. His investment will increase by 7% annual interest compounded monthly. What will his investment be worth in 2 years? And then what will it be worth in 10 years? Round your answer to the nearest dollar. Okay, so we're talking about compound interest. That is a specific set of formulas for interest, okay? I'll quickly go over these, and you don't have to memorize these. They'll be provided. You just have to know how to use them. If you're talking about compounding interest for a period, which in this case we are, it's compounded monthly. That's 12 times in a year. Use this formula, okay? If it's compounded continuously, in other words, daily, use this formula, okay? In both formulas, this one's a little easier to enter, but since we're using this one for this particular question, we'll go over this first. So it's a lot of stuff, but you just figure out what value is what, you plug it in the calculator, you get the answer. The P is your principal amount or your initial amount. In this problem, the P is $9,000. Okay? Then you have times 1 plus R divided by N. R is your rate converted to a decimal. What is the interest rate? 7%. When I convert that to a decimal, I go twice to the left. It's 0.07. So my R is 0.07. The N number is the number of times it's compounded in 1 year. It says it's compounded monthly, so that's 12 times in a year. So for this one, my N value is 12. Okay, lastly, my T value, I'm going to have two different ones because I'm answering two questions. The first T value is 2 years. The second T value is 10 years. That's it. We're going to use this, and I'm just going to fold this so we don't have to see the other equation. We're going to use this equation. We're going to type in the numbers we get, and we get the answer. And you can do this on the regular calculate screen. There's no need to type in A equals. We don't need that. We're just going to type in this stuff. P, which in this case is 9,000, then parentheses. Okay? 1 plus, I'm going to make a fraction template. There's my fraction boxes. R over N. My R is 0.07. My N is 12. 0.07 divided by 12. Okay, go outside the parentheses. Raised to the power of N times T. So I hit my caret button here to get my exponent power. N times T. N, like I said, is 12 times T. Well, I'm answering the first question. It's going to be 12 times 2. So 12 times 2. This is going to be my first answer. Okay, I got $10,348.30. Okay? So when you're talking about 2 years, it's $10,348.30. Now again, I'm going to just do copy and paste like I showed you on the last video to make my work a lot easier. They're asking me a second question about all this information. Control C, arrow down, Control V. The second question is if he has it for 10 years. So I'm just going to go and change that to this value to 10 real quickly. Hit enter. The next one's $18,087. So in 10 years it'd be $18,087. That's it. Okay, so there won't be many questions like that, but when there are, they'll give you these equations. And it's very easy to just type the stuff in. Okay, the next one. An initial population of 20 rabbits triples every year. Sorry for these typos. The function f of x equals 20 times 3 to the power of x gives the population after x number of years. Quick reminder, this is my initial value. They started initially with 20 rabbits. This is my growth rate, my growth factor, right? And it's raised to the power of x. So all I do here, go to my graph, type this equation in, y equals, or f of x equals 20 times 3 to the power of x. Make sure it matches, hit enter. There's my graph, but I want to go to the table. I want to find what it's going to be after 6 years. The number of years is my x, and the number of rabbits is my y. 6 years. I have 14,580 rabbits. That's a lot of rabbits. That's assuming they don't get eaten by something bigger than them. How many decades will it take for the population to reach 1,180,980 rabbits? So let's keep scrolling down. Okay, if you look at the yellow box that pops up once you get to these big numbers, 1,180,980. How many decades? Now, it's 10 years, but that's not what they're asking. They're asking how many decades. So you could say 10 years, but to answer their question, how many decades? 10 years are in a decade. So that is 1 decade. Next one. An investment of $5,000 doubles in value every decade. The function f of x equals 5,000 times 2 to the power of x, where x is the number of decades, not years this time. So if x is 1, it means 10 years. If x is 2, it means 20 years, and so on. It models the growth of the value of the investment. Okay, so I'm going to type this in really easily. I'll just double click on this one and change it. 5,000 times 2 to the power of x. There we go. Enter. Okay, it's over there somewhere, right? Let's go to the table. Now we got to answer these a little bit carefully. Okay, remember, every one is 10 years. That's 10 years, 20 years, 30 years, because these are not years, they're decades, as said in the problem. How much is the investment worth after 10 years? Well, this is 10 years. It's worth $10,000. How many years will it take the investment to be worth $160,000? Well, this is 5 decades. That means 5 times 10, that is 50 years. There you go. Almost there, guys. Let's keep moving on. Now we're dealing with arithmetic and geometric sequences. Again, we just have these formulas that you get used to using, and they look very confusing, but they're really not. For example, this a of 1, it just means first number in the sequence, first number in the list. Okay, so the explicit formula. A number you need in the list, like say I need the 25th number, right? The number I need in the list is equal to the first number plus the n minus 1 times d, okay? What is that n minus 1? Well, if I'm looking for the 25th number, it's 25 minus 1. And what is d? That's my common difference, okay? For geometric, it's an r value, it's my common ratio, okay? But all the other stuff's basically the same. Let's go ahead and do these, and I'll explain as we go. Determine if the sequence given is arithmetic, which means you're moving up and down by adding. Geometric, which means you're moving up and down by multiplying or dividing. So arithmetic is adding a positive or negative number. This is either multiplying by a number or a fraction, that makes it smaller, or neither if there's not a good pattern. Okay, if it's arithmetic, give the common difference. If it's geometric, give the common ratio. Well, here's all you do. You start on the end, you go backwards. See if there's a pattern of adding the same number. If not, see if there's a pattern of multiplying by the same number. So I'm going to go to my regular calculate screen. So I have negative 12.5. I'm going to put in negative 12.5. I'm going to work backwards. Negative 12.5 divided by 25. I got negative 0.5. Now, what I'm going to do here, I'm going to put in 25, divide by the one before that, to see if I get the same thing. Now, negative 0.5 is the same thing as negative 1/2. I honestly don't know why the calculator... I guess since this had a decimal in it, it gave me a decimal answer. This didn't have one, it gave me a fraction. Those are the same values. So far, I'm good. Okay? Now I'm going to do 25. Oh, I did that. Negative 50 divided by 100. Negative 50 divided by 100. Negative 1/2 again. It's all the same. So I'm dividing by negative 1/2 going down, right? That means I'm multiplying by negative 1/2 going up. 100 times negative 1/2, negative 50. Times negative 1/2 again goes back to positive 25. And so on and so on. So this, since I'm multiplying, it's geometric. And if it's geometric, we have a common ratio, and that common ratio is negative 1/2 or negative 0.5. Same thing. Okay? Let's look at the next one. I don't see all these is multiplying. These numbers aren't getting very big very quickly, right? So I'm going to see if I'm subtracting. I mean adding a number each time maybe, right? So again, I'll start over here on the end, do 32 minus 29. I get 3. Now do 29 minus 26. I get 3. Now 26 minus 23. I get 3. And yes, you could easily, some of you guys could easily just count forwards. But I want you to get this practice for the times when it's not easy to see intuitively, okay? You're adding each time. You're adding 3 each time. So it is arithmetic. The common difference is 3. The next one. We have 3 to 9 to 27 to 81. Well, let's do 81 divided by 27. 81 divided by 27 is 3. Now let's do 27 divided by 9. It's 3. And now do 9 divided by 3. It's 3. This time, though, we're not adding, we're multiplying each time. So I have a geometric. My common ratio is 3. That's how you do it. Okay, now they want us to write a formula. Write an explicit formula. That's going to be one of these. For the nth term of each arithmetic sequence. Now we know it's arithmetic, so I know I'm looking at this formula. I'm looking for one of those. I got to make one. Then find the 6th term. Okay, so what is it? The number you're looking for is equal to the number you start with in your list. What is the number I start with? 5. Plus n minus 1 times the common difference. What's the common difference? Whatever I'm adding each time. I know I'm adding because it's arithmetic. What do I add to 5 to get 10? 5. I'm doing plus 5 again, plus 5 again. That is my common difference, and that goes right here. So put times 5. That's the formula. Number 25. A of 1. Oh, you know what? We didn't finish this. I'm sorry. Now we need to get the 6th term. Okay? If I'm looking for A of 6, because it's the 6th term, it's 6 minus 1 right here. That's 5. 5 times 5 is 25. And 25 plus 5 is 30. So A of 6 is 30. And if you don't like doing it that way, you could type all this in the calculator. Just put a 6 right here because it's the 6th term. It'll give you the answer. Okay. Another way is you could just go plus 5 plus 5. That's probably the easiest way for that one. Number 25. A of 1 equals 30 and D equals negative 4. So they don't give me a list, but they tell me everything I need. It's actually maybe easier. Okay, A of n, meaning the number I'm looking for in my list, is equal to the first term, which they gave us right here, 80, plus n minus 1 times the common difference, which in this case they gave us -4. Easy. Let's find the sixth term again. 6 minus 1 is 5, right here. 5, I'm going by PEMDAS rules. 5 times -4 is -20. -20 plus 80 is going to be positive 60. So A of 6 for this guy is positive 60. Number 26, the recursive formula is going to be one of these. A of n equals a to the n minus 1 plus 10. Represents the amount of money in your savings account after n weeks. You start with $75. Write an explicit formula. So we're going from recursive, this guy, okay, to explicit, this guy. Okay, now what do you need to know? The fact that we know this is recursive, we know that that is my D number. What's the D? It's the common difference. So 10 is my common difference. And they gave us the starting number, the A of 1 value. They gave it right here, it's 75. That's my A of 1 value. Now I just write it. Okay? Again, I'm following this. A of n equals the first term, A of 1, that's this one, 75, plus n minus 1 times the common difference that I just pluck out of my recursive formula, it's positive 10. So times 10. And there it is. All right, number 27. You start an investment account with $250 and save $15 each month. How much money will you have invested after 3 years? Now, there's no interest going on here, so it looks like it's just a plain, simple arithmetic sequence. You're adding $15 every month. Your starting number, your A of 1 value is $250. So we could do A of 1. Now you could just write it out. You could do 250 plus 15 plus 15 plus 15, but that's going to be a long time because we're not talking about 3 months. We're talking about 3 years. That's 36 months. So you could do plus 15 36 times. That's pretty fast in the calculator. But let's just do the formula, okay? That formula. A of n is equal to A of 1, which is what we started with, 250, right? Plus n minus 1 times D, which is what you're adding each time. Common difference, it's $15. We want to know what it's going to be after 3 years. Well, this is monthly. 3 years is 36 months, right? 12, 24, 36. So n is actually 36, right? So let's do it. I'm going to put in 36 minus 1 right here. I get 35. You didn't have to do that, but I'm just going through everything. 35 now times 15, 525, and now plus the 250. Oops, 250. I get $775. Okay? $36 minus 1, 35, times 15, plus the original 250, $775. Lastly, the very last one. There are 10,000 cookies in a really big jar. That is a really big jar. Each week your family eats half the amount of cookies in the jar. How many cookies would be left after 5 weeks? All right. So half means it's getting smaller each time, and that's the fraction 1/2. This is not an arithmetic sequence. This is a geometric sequence because we're multiplying by half each time, all right? Our initial value is 10,000. Okay, I'm going by this formula. Our initial value is 10,000. My R value is 1/2 raised to the n minus 1. All right? Let's type it. Let's write it down first. So A of n is equal to the first starting amount, 10,000, times R, which is my 1/2 value in parentheses, raised to the n minus 1. Now they want to know after 5 weeks. Okay, each week they eat half. Okay, so I'm not going from weeks to days. It's just going to be 5 minus 1 right here. Okay, so I'm going to type this in my calculator. 10,000 right here times 1/2 raised to the n minus 1. In this case, it's 5 minus 1, raised to the power of 4. 625 cookies. That's all they have left after 5 weeks out of 10,000. That is the conclusion of the review. I wish you guys the best of luck on your semester final.